in this video, we're going to start looking at questions where we've got different compounding periods. So usually interest isn't just calculated per annum, but is calculated different compounding periods. So it could be monthly, quarterly, weekly, fortnightly, daily, half yearly, or every 2 years. I'm just trying to think of different examples, but you get the gist. So in year 12, you're pretty much looking at different compounding periods, and it's extremely important that you take note of what the compounding period is, because if you get that wrong, then everything else is wrong. This very first poster is just looking at how compound interest actually works. So if we had an initial investment of $1,000 and we invested that for 1 year at 6% per annum, the amount of interest earned over a year is different depending on how many compounding periods you have. So that's basically what we're just looking at here. So in January, we invested the $1,000 into 4 different accounts. So if it was monthly, you can see that we've got the amount there every month. Quarterly is every 3 months, because if you think about 12, if we divide it into 4 into quarters, that's 3 months. So that's why your next one would be in April. If it was weekly, then obviously we've got time in between. Now that's assuming 4 weeks in a month, so it's probably not as exact, but kind of worked off that theory, 4 weeks in a month, and then fortnightly, 2 fortnights in a month. Now, there isn't exactly 4 weeks in a month, and then there's not exactly 2 fortnights in a month, and there's not exactly 52 weeks in a year or 26 fortnights in a year. But in general maths, we work off those two values. So 52 weeks in a year and 26 fortnights in a year. So don't go being fancy and saying it's 52 point blah blah blah, just 52 weeks, 26 fortnights. Now if I just scroll down, and that's what I wrote in the next one. All right, so you can see after 1 year the different amounts. Now this one here is the highest because we had more compounding periods. So this one had 12 compounding periods, quarterly 4 compounding periods, weekly is 52, and fortnightly is 26. So the higher the number of compounding periods, the more interest you're going to earn. So if I had daily there, you would actually get more. Now I'm going to just show you quickly on the calculator how to do this, and then, because I'm just curious at a few things. All right, so I'm going to clear what I've already had there. Let's just clear the page. All right, so we're just going to look at 1 year. So N is the number of compounding periods. So I'm going to do monthly first. Actually, oh yeah, we'll do monthly. All right, my interest rate is the same for all of them. My principal value, so we'll talk about this soon, but you're investing money, it goes to the bank, so it actually is a negative there. We're not putting in any payment, so that's just going to be 0 when it decides to work for me. And then PY and CY are going to be the same. If you're ever unsure what these are, you can just go to help and it tells you. So this PY and CY is 12, so that's how many compounding periods there are. So there's your future value, which we've got written down here. All right, now if I change my number of compounding periods, what was the next one? Quarterly, so we're going to change it to 4. Just make sure we do that with these two as well. And then we want the future value of that, so it's a little bit less. Doesn't look like much, but we're only investing $1,000, so not going to really change that much, but over a longer period of time it would. So here's your weekly. Oops, no it's not. Let me just press on the button. So that rounds up to $1,061.80. And then obviously we've got our last one, which is fortnightly. Oops, I keep pressing enter instead of the future value. Now, if I was to do daily, which obviously is probably the highest number of compounding periods you will have, because we don't do hourly or anything like that. and you can see it's slightly more. Now, if I was to do that over, let's say 10 years, all right, so there's that amount there. So over 10 years, let's just think of it as $822 interest. If I was to do that quarterly, so 4 times 10, and your calculator will do the 40 for you. You don't have to actually calculate that. So we had 1,822, so $822 interest. And this one here, did I make a mistake somewhere? Oh, didn't change that. Silly me. It's like, why didn't it go up that much? All right, and there is 1,814. So we had a lot more money when we had it daily. So I can't even remember what it was now. 1,814, and let's just change it back to daily. Gosh, I have a terrible memory. Oh, what did I do wrong? Oh, didn't do times 10. So just add a 0 there. So we earned, what was it, about $8 extra, which doesn't seem like too much, but we're also not investing too much anyway. So $1,000 isn't much. But if you had a home loan, so let's say it was $1 million home loan, so let's add a few more zeros on there, then obviously it would be quite a lot more. All right. What I've got written here is what your number of compounding periods per year. So there's 1 year in a year, obviously, 365 days, 52 weeks, 26 fortnights, 4 quarters, and you might have half yearly, so 2 half years. All right. Now looking at recurrence relations with different compounding periods. So I might go over this and then we'll have a look at the questions. So we do have the same recurrence relation as before and the same rule. It's an example of geometric growth because we've got compounding periods. N is how many compounding periods you have. So in the past, because we've only done yearly, we just substituted in the number of years. But if you were doing weekly and for 5 years, it would be 52 times 5. So just make sure you get your value of n correct. Now your common ratio will depend on what your compounding period is. So you just use this rule here. So your common ratio is equal to 1 plus r over 100 times p, where p is how many compounding periods you have each year. All right, so if it's just yearly, p is equal to 1, so it's just r over 100 like we've done before, but I've got all the different common ratios here, so daily, weekly, fortnightly, half yearly, quarterly, monthly. All right, so you can see just how many compounding periods there are. So that's, you're using the same recurrence relation and the same rule, it's just your r value is changing. We might talk about the effective interest rate. Oh, let's talk about it briefly and then I don't know whether I'll do it in this video or a separate one. So with your effective interest rate, so let's say you walked into a bank and you're like, all right, I'm going to get a home loan, and it has this big poster and it says, get a home loan with us, we charge 6% per annum. Now that is what we call our nominal interest rate. So that nominal interest rate is kind of like the advertised rate. What it actually works out to be is your effective interest rate. And your effective interest rate depends on how many compounding periods you have. So let's use the example we had before. So it was 6%. So on your calculator, it's easy, very easy to do. We've got this rule, which is also, I mean, it's on your formula sheet, but it should also be in your bound reference. I've never seen a question where it needs to be used, but you never know. Could be a show that question, and you need to be able to just substitute in for r and your value of n. So it looks more complicated than it necessarily is. All right, so go to interactive, financial, and interest conversion, and we're going to convert the 6% into the effective interest rate. So we've got N is our number of compounding periods. So if I was to just do it yearly, it'll stay the same. So one compounding period, if it was yearly, per year. All right, so it stays as 6. Now, I'm not going to rewrite that. I'm just going to change this here. So if I wanted to do it, let's start off with the 2, so half yearly. Let me press enter, please. Should change. All right, so it's 6.09. Let's change it. It's probably good to put it on the different ones. Let's change it to quarterly. Let's change it to monthly. Let's change it to fortnightly, so 26. And then I'm going to do weekly, so 52. And then I might do daily, so 365. So you can see the amount of interest, or the effective interest rate, increases with the number of compounded. So if you're let's start again. As your compounding periods increase, the effective interest rate is also increasing. So it just stays the same, and that should be, change that to 1. I don't like that because it's not right. Didn't press enter. Stays the same as 6. Half yearly, it's gone up a little bit to 6.09, but as you can see, it keeps increasing as the number of compounding periods increase. So even if you walked into the bank and it was advertised as 6%, you're actually paying a little bit higher with the effective interest rate. You can go, if you're given the effective interest rate, you can go back to the nominal interest rate. So you would have seen that as the other one, convert to nominal. So the number of, let's just do half yearly because it was a nice easy one to remember, 6.09. It's going to let me enter it. It should come up with 6. Okay, so it's just basically the inverse of what we've just done. Now you can find these in Action. The only thing is it doesn't prompt you. It just has the prompt, not the prompt, what would you call that? I can't think. The program. All right, so it's already there for you and you can put it in. I do prefer the interactive menu because it prompts you. Action doesn't prompt you. All right, so you need to be really familiar if you're using the Action. Interactive, I mean, it doesn't take that much longer to actually use it. So all good. All right, let's get some questions done. Oops, let's actually open the right document. All right, so for each of these we need, so the annual interest rates, and we're converting them to their different time period. So if you've got monthly, you're just dividing it. So 4.8 divided by 12 and so on. Pretty straightforward. And this one here you would be multiplying. So 0.54 times 12 to get the annual interest rate. So just remembering the number of compounding periods and so forth. All right, so let's have a look at maybe doing these two questions. So a principal value of $8,000 is invested. Let me just highlight. In an account earning compound interest quarterly at a rate of 4.8% per annum. So your interest rate is usually given to you per annum, so the yearly interest rate, but it will then tell you what the compounding periods are. So write a recurrence relation for the value of the investment after n quarters. So it's, oh, there it is. It's compounding quarterly. I was looking for the word quarterly. All right. So if you're unsure, you go to your notes. All right, here is quarterly, guys. All right, so there's our R value, 1 plus little r, which is your interest rate, over 100 times 4. And your recurrence relation is here. So same as before, Still calculating, or still writing the same. V0 equals your starting value, Vn plus 1 equals your common ratio times Vn. All right, so V0 equals 8,000. Vn plus 1 is equal to, now our common ratio is 1 plus R, which is 4.8 over 100 times 4, and that is times our initial, Vn. All right, so we can just pop that into the calculator. So the 1 plus, let me just get rid of that. Excuse me. Doesn't like it when I fold my computer over to write on it. All right, 1 plus 4.8 over 100 times 4. So 1.012 Vn. All right, so there's your recurrence relation. Now writing down the rule. All right, so again, we look at our notes. Here's the rule. All right, so we've already calculated the value of R. It's a bit hard to see because I've been writing on things, but there is an N there, so let's just get rid of that. So R to the power of N. So Vn equals 1.012. We calculated R before, to the power of N times your initial value, which is 8,000. Use this rule to find the value of the investment after 3 years. So often it doesn't tell you this little bit of extra information, 12 quarters. So 3 years, always think about what N is. Because our compounding periods aren't yearly, it's going to be 3 times 12 because it's, not monthly, sorry. Should be 3 times 4, which is 12. All right, so that's where the 12 has come from. So V12 is equal to 1.012 to the power of 12 times 8,000. And you can just pop that into your calculator. Actually, I'll do it because I want to make sure you do your rounding correctly. 1.012 to the power of 12 times 8,000. 923116. All right, so after 3 years or 12 quarters, you have earned $1,231.16 in interest, which is pretty good. All right, let's have a look at this one. So Wayne invests $7,600 with a bank. He will be paid interest at the rate of 6% per annum, compounding monthly. So let me just highlight a few things. There's our initial value, our interest rate, and it's compounding monthly. We've got to write a recurrence relation. We've got to write a rule. How much is it worth after 5 months? How much will it be when it first doubles in value? Okay. So let's have a look at our recurrence relation first. So we're always going to start with V0, which is our initial value. And then we've got Vn plus 1 is equal to R. So our value of R is 1 plus little r, our interest rate, over 100 times the number of compounding periods, which is 12. And then we're multiplying that by Vn. All right, you can finish that off. I'm just conscious of time. You can pause and do that. Write down the rule. All right, so I'm going to do this one because we're going to use the rule for C and also D. All right, so Vn, remember if you're ever unsure, you go back to your notes. You need to be using these, being familiar with them. All right, you don't write your notes after you've done the questions, or you shouldn't have these after you've done the questions, have them before. Obviously, you can still write notes after you've done them. Okay, so I have to do the common ratio anyway. Oops. All right, so 1 plus 6 over 100 times 12. All right, so 1.005 to the power of n times V0, which I was about to write, times 7,600. All right, so for part C, 5 months. So n is equal to 5. It hasn't even gone past years. It hasn't told us years, so n is just equal to 5. So V5, and I'm just going to put that straight into the calculator. It's not a show that question, so I can just pop it in to the power of 5 times 7600, 779191. Now, obviously, you can also do this in your sequence. It's only 5 months, so it probably wouldn't make any difference. You know, you're not scrolling for forever. After how many months will it double in value? So we want Vn to be, oh gosh, I'll just get rid of that. We want that to be greater than double 7,600, which is 5,200. No, it's not. It's 15,200, silly Billy. Yeah, just had to check that. All right, so we want it to be greater than 15,200, so we can do that on our calculator. All right, so let's get that on. We can just solve that if the calculator wants to work. So 1.005 to the power of x times 7,600, and we want that to be greater, so I'm just in math 3, 15,200. All right, so it has to be more than 138.97, so we round to the nearest integer or nearest whole number. So it's going to be 139. And it just says months, so we can just leave it as months. If we had to convert it to years, we would divide it by 12, but it just says months, so that's fine. So you can see how high that is. So if we were to put that into the sequence thing, it would be quite high. So what I mean by that is if we did it in here, I might just flip my computer. It's going to be a lot quicker, and I don't think I need to do any more writing in this video. So my recurrence relation is 1.005 times AN, and my initial value was 7,600. So if I went and did it here, so we want it to be doubled. All right, I'm not going to get high enough. So I could change it here, but I would be changing it over and over again. So if I go to 150, obviously it's not going to take too long to find it. So you could also do it that way. What did we want? 15,200. So oh yeah, 139. Oh, I had in my head 140. Anyway, guys, I think that's it. I don't think there's another question to do, but most questions we will do from this video onwards will be more complicated than this. So please make sure you understand just the basics of arithmetic sequences and geometric sequences, because every question we're going to do from now on will be combining the two of them. So this one here is a investment. So let's say Wayne invested his $7,600, but he added to that monthly as well. So that's where the arithmetic sequence would come into. So we'll do those questions later. All right, bye.